Question 9. A circuit is connected as shown below. The battery has an EMF of 10 volts and an unknown internal resistance R. A voltmeter V1, you can see voltmeter V1 in green, is connected across the battery, and another voltmeter V2, you can see it in blue, is connected across the switch S. This is switch S. The connecting wires have negligible internal resistance. So let us study the circuit. We see that we have a battery component with two cells and then an internal resistor. The battery is having an EMF of 10 volts, and then we see that there's a wire connecting from the battery to the two resistors, the 5 and the 10 ohm resistors, which are in parallel. Then the connecting wire continues. We have a switch there, and then we have the circuit continuing after the switch to the 2 ohm resistor and then to the battery. So this is a circuit that we have. Now let's look at the questions. Switch S is initially open. We can see that one. Then 9.1, write down the reading on the voltmeter V2. Now we can see that voltmeter V2, the blue one, is connected across the terminal. We can trace it and see that it is coming from the battery on this side, and then on the other side of the switch is going through the 2 ohm resistor and then to the negative terminal of the battery. So the voltmeter is connected across the terminals of the battery and the switch is open. So when it is like this, the voltmeter reads a maximum voltage, which is the EMF. So the reading of the voltmeter V2 as it is now is the open switch voltage, which is the EMF. And then we can write the answer down as the EMF, which is 9.1. Then let's look at 9.2. It says the switch S is now closed. So when this switch closes, now current begins to flow through the external circuit. So we have current. So what is going to happen is that this switch now becomes a point of zero resistance. You have to remember that the resistance in a switch is 0. Therefore, the voltmeter V2 now becomes connected across the terminals of the switch with the switch closed. So it will read the voltage drop at the switch. And since the resistance inside the switch is 0, it means the voltmeter V2 will be reading 0 volts. So let us check and then write the answer. For 9.2 is 0 volts. Then we look at 9.3, which says calculate the total external resistance of the circuit. So here to calculate the total external, we see that we have a series, that is the 2 ohm resistor in purple, connected in series with this parallel section, that is the 5 and then the 10 ohm. So to add them together, we add the parallel first, because we have a parallel inside a series. So we add the parallel first, then we now use the series method to add this section and then the 2 ohm resistor together. So let us see how we work this out. First, we have to use the parallel formula. 1 over R parallel is equal to 1 over R1 plus 1 over R2. Then we substitute the 5 and then the 10 ohm resistors. 1 over R1 becomes 1 over 10 plus 1 over 5. And then when we add them together, you use a calculator, you enter this, use the fraction editor to enter this one, and then you add them directly. But remember, when you are looking for R parallel, remember to turn it upside down by using the x exponent negative 1 key on your calculator. Then that gives you 3,33 ohms for the parallel section. Then the total resistance of the circuit now is the total external resistance, which is equal to the parallel section 3,33 plus the 2 ohms. I'm talking about this ohm, this 2 ohm, the purple one, and then plus this parallel section, the total resistance here. So that gives us a total resistance of 5,33 ohms. Then let us look at the next question, which says that calculate the internal resistance R of the battery. And this is 5 marks. So it means that the steps are a bit longer, that there are more steps involved here than the previous question that we've just solved. But let us analyze the question first. To get the internal resistance R, it means that we have to include all the total resistance, including the internal resistance, which means that we have to include the EMF. And then we have a formula for EMF that connects the external circuit and then the internal circuit. So you go to the formula sheet and then look for that formula, and then you write it down first. But before you even do that, you must determine what are the quantities in that formula. What are the quantities in that formula? Are they all available? If there is one that is missing, we have to calculate for it. So we see that in that formula says E is equal to I into R external plus R internal. Now, which means that we need to know the I, which is the total circuit current, and then R external, which we calculated, and then we also need to know the EMF. The EMF is here, and then the only unknown should be the R. But we see that we don't have the total current, so we have to first calculate the total current. Now let's go back to the problem and check here. They say that when the switch S is now closed and the reading on voltmeter V1 is 8 volts. That is, this green one is now reading 8 volts. Remember that it is also connected across the terminals of the battery. So it's going to read, with the switch open, it will read 10 volts, the EMF, just as V2. But with the switch closed, this internal resistance now takes its voltage, which is called the loss voltage. It will take it, so there will be a decrease in voltage from 10 to 8. In fact, we can say that the loss voltage here is 2 volts. So with the switch here closed, it means that this V1, which is green, the green one, is now reading the external voltage, which is the voltage of the battery minus the lost volt. And then this is what we use to calculate the current. So let us look at how we work this one out. Now that is 9.4. We write the formula for Ohm's law. R external is equal to V external over I. And then when we substitute, we've already calculated R external as 5.33. We substitute the 8 volts we were given, and then we are left with current. We change subject, and then we get the current to be 1.5 amperes. Then we are not yet done, because the question says to calculate the internal resistance. So we have to bring in the formula for the EMF and the internal resistance, and that is E is equal to the I, that is the total current, into the external resistance plus the internal, and that gives you a mark. And then when we substitute, we get 10 is equal to 1.5 into 5.33 plus R. And then when we use calculator and we work this one out, we get 1.34 ohms at the internal resistance. Then let's go to the next question, which says, now how will the reading on the voltmeter be affected if the 5 ohm resistor, they are talking about this 5 ohm resistor, was removed? Choose from increases, decreases, and stays the same. Now, when we remove this 5 ohm resistor, how is the total resistance at this section, the parallel section, affected? Remember that when the circuit is working, these two resistors have a total resistance that is less than any of them, and we calculated that one to be 3.33. So if we remove one now, which if we remove the 5 ohm, then the only resistor left here will be the 10 ohm. So that increases the resistance at the parallel section from 3.33 to 10, and as a result, the total resistance of the circuit will increase from 5.33 to now 12. And remember the relationship between current and resistance. As resistance increases, what happens to the current? The current decreases. So when current decreases, then it means that our lost voltage, remember lost voltage is a function of current. The more current you have, the more current you have, or the more the current going through the battery, the more the lost voltage. So when anything that increases the current will anything that increases the current will increase the lost voltage, but anything that decreases the current will decrease the lost voltage. Now, when resistance increases, total current is going to decrease, and as a result, the lost voltage will decrease. So when the lost voltage decreases, then this voltmeter now will be reading a higher voltage, because the EMF is still the same. The EMF is still 10. So when the lost voltage reduces, it means external voltage will increase. And so we can write this one, the answer here, as 9.5 is increases, and then 9.6 is saying that explain your answer to question 9.5 for 3 marks, and then the answer to that question is the total resistance will increase, and then as a result current will decrease. We are applying the relationship between current and resistance here. Then lost volts will also decrease because lost volt is a function of the current. And then when lost volt decreases, the total external